it's spinning, it says it's going, and you are live. Well, I'm live. I don't know about you. Hope you're live. Hope you're live, doing well. Welcome to the stream. It is a wonderful Friday. I know it's been a while since we've had the last stream, but yeah, life. I don't know if anybody else checked out the short that was on the channel that we have been starting up some equipment, some alpha controls equipment. Welcome to the stream. If this is your first time here, my name is Jason. I am a founder and CEO of a little automation company out of Tuscaloosa, Alabama. We do light industrial OEM design, we do agriculture work, and we also do kind of data-centric stuff using Ignition and Siemens. I've got about 24-ish years of experience working with Siemens. I got an early start. And so started working with the master drives at a pretty early age. So today we are kind of catching up. We are going through and it's been a little minute. Had a couple of weeks where been out of the country, out of town, not able to kind of work on this sort of stuff. So yeah, it's good to be back, and it's good to be doing all of the fun stuff that we've got going on. So if you are coming in and let's see, you were just joining in, drop a like on the stream as you're coming in, because these streams are long enough to where as people are coming in to lunch and stuff like that, if you're liking the stream, it gets it out there to more viewers, and that is how this channel grows. And yes, got Measure Once is in the stream. Good to see you again. Good to see some familiar faces on the stream. So yeah, as always, when you drop in, drop a hey or a hi, where you're from. This is usually a pretty international broadcast. I feel like I'm dark. Am I dark? I don't know. I definitely am not dark complexion wise. I'm talking about the light here. It seems like normally I have this like blasting in my face. Maybe it's just me. There we go. That's better. Anyway, yeah, T Ferg, hey or hi. Hi from Mars. It's good. It's good to see some Martians online and people that are very serious at learning about automation. Also, tell me if my voice is loud or too loud, or I'm clipping, because I don't know if y'all have noticed this, but my videos have been like quiet, and I feel like it's hard for me to get the right settings on the audio, and I feel like it's going a little too far today. So I'm going to turn this gain down. From North Pole, Finland. That's awesome. Bilal, another familiar face. Sweet. I'm glad that the audio is good. Good to see back from Finland. And I mean, if you're from the North Pole, does that mean that you are automating Santa's workshop or something like that? Oh, bad jokes. This is my first cup of coffee today, so I'm probably going to get more coherent as we go through the stream. But today we're talking about some fun stuff. So a little background. I got an email, actually, from I got an email from some guys. I think they're in Belgium. Some grad students in Belgium working on a project, asking some interesting questions about how to use technology objects on third-party devices, and kind of opened up the brain juices here. So if you didn't notice, I'm wearing my original Siemens expert or Siemens Drive expert shirt. I don't even know if they give these out anymore. Measure Once probably knows, but Measure, if you're still in there, do they still give these shirts out to like certified people for Siemens distributors? I don't know, but I'm wearing my Siemens Drive Expert. It says you can't really see it, and I'm lazy and I don't want to stand up. It says S120 certified engineer, and it means nothing really because I haven't gone through the certification process in years. But I have the shirt, and we're wearing it today because we're talking about some cool drive topics. Yeah, so these guys in Belgium reached out, and they were wanting to control use some of the kinematic objects for it's a Delta picker that they have, and it's a third party drive controls on this Delta picker, and we're going to go through all of like what all this stuff is, but I realized and it's using Modbus, and again we'll go through it, but there's a couple of different options in the technology objects, and Modbus is not one of them. If you've used any of the Siemens technology objects, you know that your options are essentially if it's in the device hardware as like a Profinet Siemens piece of equipment, or if there's an analog coupling. But we're going to be talking today about the Datablock connection for the technology object. And we'll go through some of these more advanced topics. And then after that, we'll kind of do a little bit of introduction to some HMI scripting because, well, frankly, I've been asking about it. I've had some of my longtime commenters on the stream and on the channel asking about kind of doing these HMI topics, and frankly, I think people like them. So we get through the technology object discussion. Probably the first hour or so, the second hour or so should be the HMIs. Hopefully I got enough to talk about. I mean, I don't really know how to talk for any time, so we might have a short stream. Probably not. But let us get started with something here. I realized something. Hold on. I didn't get my music for me going. So let me do that. Yeah, so anybody been involved in any sort of interesting projects? If you have, tell me what you're working on. Put it in the comments or put it in the chat of what y'all are working on, because it's kind of funny, or it's always we always have these weird. Sometimes you have like the mundane projects that are kicking your butt, and then you have the like fun projects that are still kicking your butt, but I don't know, they seem worth it. So what do y'all have going on these days? So while I get the volume turned down on my music, because otherwise when I enable that, it's going to be crazy. Why is it not doing anything? Okay, what's that going to be? Let's see. But yeah, sorry for not being completely ready. We had an issue with our project that we were working on today. I had to work out a couple little details, and we were kind of hopefully finishing that up this morning. So didn't quite have time to get the whole stream all together. And so let's see let's play this one because this is the loudest one. Okay, yeah. All right. So we'll do this. We're going to put it on repeat. We'll mix it up. And we will go from here. And that looks like that's going to be a little too loud. Okay, there. Let me know if that music's too loud. Again, I need the music for me, but also just makes a little bit more fun, I guess. But yeah, let me know if that's too loud, if it's distracting. But yeah, so let's get going on TIA Portal. So we're gonna start with our project that we started a couple weeks ago, our Winder project, and we're gonna use that as kind of a jump off point. And my face is in the wrong place, and there, that's a little better. Because what we're gonna be doing, so this is our Winder live project. And yeah, we're going to start from this, and we're going to add in some technology objects after coffee break, of course. Yeah. So again, if you are coming into the stream, be sure to drop a like on the stream so it gets pushed out to more people coming into YouTube on their lunch breaks and coffee breaks, so that they can join in and they can learn about Siemens technology objects. So currently on this winder, or this kind of setup winder that we did a couple weeks ago, we went through and set up a couple of S120s, and I noticed that because we set those up as not servo, so they are in vector control, the telegrams that were available to us are limited, because last week or a couple weeks ago, we were wanting to use our Siemens 352 telegram, which is wonderful for vector control. So if you're using a G120 or G120 or an S120 with like a standard induction motor, the 352 telegram is amazing. That's what I use for all of my G120 applications. But I noticed that the telegram that I like to use on kind of our technology object is the Siemens 103 telegram, and it is not available for vector objects. So there's a standard telegram 3, but I like using the 103 because it has a little bit more information in it. If you don't know about the telegram numbering, if it's just a less than 100, that is going to be an ISO certified, like an ISO standard telegram. So that's not specific for Siemens. That would be for Mitsubishi, Yaskawa, like anybody else that uses those telegrams. That's going to be the configuration. Is going to be like a 1, 2, 3. Those are industry standards. Anything over 100 is going to be a Siemens specific telegram. So even stuff for like your encoders are like 80s. It's like 82, 83, stuff like that for external encoders. Those are standard telegrams, but then you have other telegrams that are available for Siemens that are above 100. I like using that 103. So first thing I want to do, and don't ask me why I'm doing this, is I remember this as I'm talking about telegrams. I want to delete some stuff out of here, because I was kind of playing around with this last night, and I want to show y'all. The dang 611U. What? Anyway, I wanted to show y'all kind of like a clean version of how you would want, or how you would do this, and if you were doing this sort of project, how it would work with you. So what we're going to do right now, we want to make a couple of technology objects. Actually, first thing, let's just do this. Let's see if we can totally mess this up. I want to go to properties here, because I want to change these to servo, and then change these drive telegrams, because we're not really going to be using any of the stuff. This is just our like free, and in 103 is not available, like I just talked about ad nauseum. So what we're going to do is we are going to go up to device view, and we have to go to these individual devices. So click in this like grayed out area. The dark gray means it's fully configured. If it's light gray like this, it means there's something that's not quite configured. So what I'm going to do is I'm going to change this to high dynamic servo for all of these, and it'll pop up this little dialog box that's like, hey, it will delete all additional components and reset the parameters. So we're going to go through and real quick reset this up all in servo. Now, one thing to note is that yeah, so measure, that's the thing, that so measure once, cut twice. He's actually yeah, he's close to my heart. He's my replacement at Wesco. So he's asking, uh, he is asking whether or not these data types that I just are part of a Siemens library, they are actually built into Portal. You just have to know how to access them, and that's what we're going to do. You just kind of have to, once you know what the telegram that you're using, there's just something, a certain thing that you could type in, and it just works. And so, and it'll actually import them into this system data types here. It'll import it into automatically. So there's a lot of like, oh gosh, stuff that from me playing around with, it imported. But all of those will import in, like if you need them and they are available in the system data types, kind of like library built into Portal, it'll import them into that. Yeah, it really is awesome. So first thing, let's get these, last thing I'm going to talk about the hardware, then I'm just going to blow through this hardware real quick. These control units can control up to 6 vector or 6 servo drives. No matter what, it's 6 is kind of your limit. You can do 12 volts per hertz drives on them. And so, but the problem is you can't mix and match servo and vector. Save live. So not sure what the question is. Ali Reza. Is this the Ali Reza? So Ali Reza Farouja for all of you chess people out there. Are you asking whether or not you can save what is online, kind of do an upload? If that's your question, yeah, we could talk about that. But on the one thing I was wanting to say about mixing and matching servo and vector drives isn't allowed on a single control unit. So a single CU320, it has to either be all servos or servo and volts per hertz, or it has to be all vector or vector and volts per hertz. So you can't mix and match servo and vector on one control unit. And so I have a project that we have multiple control units, and we put all of our servo control. So anything that you want to use Telegram 103 needs to be in servo. If you were wanting to do vector control, like for a standard BlackMax motor or something like that, you're going to absolutely have to have 2 control units just for that. Fortunately, in our situation, we had like 8 motors that we were running on this system anyway, and so we had 2 control units, and I put 6 servos on one, and then did everything else in vector control on the other. So just one thing to note. Let's throw some motors in here. Ali Reza, if you're asking whether or not you can upload what is live on here, you can. There's a trick in Portal. If you are wanting to upload into Portal, say like the drive unit, everything has to be offline. So you could connect up to the PLC, connect up to the drive to make sure you have the connection, but then you have to click here and then go offline on everything, and then make sure everything is offline, and then you can click this and click upload, and then that'll load. Same thing with the PLC. You can upload your program blocks if you have the project, and it'll upload it off of that if upload is permitted in the project. If you've been on the stream a couple of times and you've seen me like bring in a PLC, then you'll see this kind of like dialog box that pops up, and it talks about, do you want to enable these protection settings? And if that's the case, then if the protection is made to where you can't do an upload, then you cannot save what is live on the PLC without a password. There is the same protection on the S120 as well, but it's just a little a little bit deeper built in. Hopefully that answers your question, and welcome to the stream, as always. And so, yeah, again, as you're coming in, if this is your first time, welcome. This is usually pretty international crowd. So glad that most everywhere else is able to speak English. Sometimes I don't do it well either. So, but sometimes my redneck will come out. And if you're not familiar with what that is, yeah, it's okay. we in the south of the U.S. You save this live. Yeah, so the videos on demand, if that's what you're asking. Yeah, so the live stream is available to watch always, but the best way to get access to that, is to subscribe to the channel. But yes, I have a playlist that yes, have a bunch of TIA Portal tutorials that are also available on the channel. And yeah, if this is first time coming across this channel, yeah, we have a lot of information. There's a lot of edited videos that are a lot more concise. Then we have really a lot of content in these live streams that I try to go back through and put in chapters to make sure that it's a little bit easier for you to get the information out of. But yes, we do save all the live streams, and they are available forever. Well, I don't know, as long as YouTube keeps them up. So we've got our drive switched over to Telegram 103. And the reason I went ahead and did this is because I wanted to show you the difference between working with a Siemens drive and something that we might have like a, let's see, I'll show you this, because like if you have I think we have V90s in here. V90, yeah, Pro V90. So I'm going to throw this V90 in here and assign it to this controller. And we're going to give it a telegram. Actually, I don't even know if we can do that here. Yeah, we can. It's right here. Because I'm gonna show you this here, because submodule we're gonna do. Okay, so we can do a Siemens Telegram 102. Let's see if we can actually make this work, because this has a GSD file with these telegrams. So I might be winging myself into yeah. Yeah. We got some cool stuff coming. So let's add a new technology object. So ultimately we're wanting to do a delta picker, and we're going to need to have positioning axes, because what we're going to get into today is having this kinematic technology object. And in order to have kinematics, if you're not familiar with kind of the way that the technology object concept works, is a technology object is a dedicated data block. Yeah, okay. Yeah, so the technology object is a dedicated resources on these motion control resources on these PLCs. Your standard CPUs, like a regular 1500, can do what's called standard motion control, and those are speed axis, positioning axis, and even a synchronous axis. Those are the standard motion control. These camming kinematics require a technology CPU, so that's why we have this 1515T processor. And the way this works is it creates a data block that your program interfaces into the technology object, and then you configure the technology object differently depending on what type of hardware is out there. So the program you write, as long as you have a technology object of the same type, it just works. And then you can reconfigure that that output to either be a Siemens drive, a Siemens G120, S120, V90. We're going to be showing about how to use analog connections and even the most advanced connections of today about how to set it up via Modbus TCP, which, yeah, it's really advanced. But the concept is that you can use the same code to control many different types of drives. You could even do a hydraulic motor with this. So if you're not familiar with the way hydraulic motors, there are actuators and flow control valves for these hydraulic motors that are based on an analog output. Well, we can connect up this analog output. We can connect up this technology object to just send out an analog output and then bring back an encoder signal that we set up differently. So we're going to make 3 axes of positioning axis objects. So we're going to have 3 technology objects of the type positioning axis. And we'll get into this here in a second, because if you understand the concept of just your basic technology objects, the Kinematics technology object goes a step further. And instead of interfacing in with the drives, the Kinematics interfaces in with other technology objects. So it's like recursion inside of that. So you have to have these technology objects set up, which you can modify the hardware on those, and then you can have this Kinematics object over the top of it. And so you have three technology objects, and then you have this plugin, this kinematic, that operates all 3 of these. And then so you're interfacing in with the kinematic technology object and then going from there. So what's the cool thing about it is, if we go in, and if you notice, I haven't configured any of the axis 1, 2, or 3, and delta TO. And we want to go in, and I don't have to have these axes fully configured, I believe, to be able to do this. And AliReza, that's a great suggestion. While this is loading in, it'll take a little bit. AliReza's asked to kind of a video about an induction motor look like a servo motor, and there's a couple of different things that are interesting about that thought of, does a servo motor, or I guess a servo motor, most people think as a permanent magnet motor. Like, I think I have one sitting around here somewhere. Hold on. So most people think that this is a servo motor, and it's a 1FK7 permanent magnet motor. So there are windings on the outside of this motor, and then permanent magnets on the actual rotor. So if we were to take this motor apart, there would be magnets on here. So this is what everybody calls a servo motor, right? Because this motor has to have servo control in order to run it. Well, the thing about it, you can actually run an induction motor in servo control and get decent performance out of an induction motor. Not nearly the same performance as that servo motor, but you can run an induction motor in servo control as long as you have an encoder. And so there are actually a couple of motors. You know how I said earlier that I had the system that had the 2 control units, and I had too many objects that were on on one control unit, and I was kind of having to jumble them up. Well, a lot of those actually are induction motors. That the winder that we've made is actually using 1PH8 motors, and they are induction motors. They don't have permanent magnets, so they're not servo motors, but they are running in servo control. And what servo control gives you is it just says, hey, the position is coming from the encoder. I don't have to calculate the speed. I don't have to do anything. I'm just going to look only at the encoder and not calculate a model, an induction model. And so we'll definitely talk about those later and on another stream, because that is a very good topic. So we've got this kinematic description pulled up, okay? And if you notice that this is it's pretty cool. And so you can pick all of these different types of kind of robots and kinematics. And so kinematics is just the mechanical description of a electronic control of a mechanical description. So the kinematics are the mechanical kind of description of this. And ultimately, you want to get your end effector. You're going to be sending it commands like move XYZ, and it's going to have a certain, like if you've ever used like a KUKA, ABB robots, like actual industrial robots, the way that you program those is you say, hey, I want to make a path. And so instead of controlling the motors directly, you just say, I want this point here to move in a certain path, right? I just want it to kind of move around like that. And so all you're sending to this technology object is the path in order to move. And then the technology object sends down the control to the other motors in order to make that happen. So you pick the mechanical type that we're wanting to do. And what we are wanting is what is called a 3D delta picker. And if you've never seen one of these, they're pretty stinking cool. So you have your 3 motors, and they are all in the same plane. So you have a flat plane. So you're not having to have like an XYZ type setup. And all 3 motors don't move. And because of this, your end effector has very, very low, or can have very low inertia. And so you can move really fast and accelerate really fast on this. And we're going to be putting some of these together. And yeah, so the next thing we're going to do is just these interconnections, okay? So we want to interconnect axis 1, axis 2, and axis 3, and we're good to go. Green means go, right? And the next thing you would do on this is go through each one of these geometries. And so the length of the arms, say they're 100 millimeters. Length 2 is the length of the second bottom part of the arm. Say it's 100 millimeters. And then you kind of go through all of these other different things that you have here. So the distance from the actual center point of the device to the actual shaft center point. Let's say that is, say that's 30 millimeters. And then distance D2, same thing on that. Let's say that's 15 or 10. It's really small, I know, but we're just putting these in. So our axis angles, we're going to say 120. Is that not right? Yeah. 120. Yeah. So that's really all you have to set up. And then there's all sorts of cool stuff that you could get from here. So like conveyor tracking, for example, if you have a positioning axis that is a conveyor, it can go through and automatically take that end effector. And if you say go to a certain point, it will go to that point and automatically track according to that conveyor. Super, super cool. If you I guess if you haven't seen videos of how fast these things can operate, you really need to look it up. And there are a lot of pick and place, like the downside to this Delta type picker is it doesn't have the range of motion inside, like the envelope of motion is really weird. So if you're directly below, let's go back to this. So if you're directly below this object, you can kind of get the full extension away from this plane, right? Well, if you get off to the side, like if you deflect like over here somewhere, then all of a sudden you can see how the motion of those arms have to be able to like work in order to do that. And it's going to make it to where it is very difficult for this configuration to get over here. And so it creates this kind of like weird cone shaped envelope that you can work in. And yeah, what it does really well is if you were kind of at some level that's to where these are kind of close to parallel, it goes really well up a few inches and over. And so it does really good at sorting from two conveyors, like back and forth. And it can do it lightning fast. And so these are really cool and built-in kinematics for this. So we've connected up our 3 axes, right? So really there's a lot about the kinematic objects, and we might talk about that in a little bit if we have time. But there's a whole set of like MC instructions that are for the kinematic object. Instead of like MC move absolute, you have things like MC move linear, and if you've ever worked with like an actual robot company, again, like KUKA, FANUC, ABB, any of these like industrial robots, you have these instructions that are say, hey, how do you want the joints to move? Do you want the pin on the end of your end effector? Do you want it to move in a straight line, or do you want it to move in a circle? Like, do you want it to move around like this? Like, how do you want that end effector to get from point A to point B? That's the type of instructions that you have for the kinematic object. Whereas you can get down into moving just one motor. But I mean, think about it. The complexity that's built up into this design of these three motors acting together and moving this endpoint around, like up and down and all around, is pretty crazy. So, yeah, let's go through now and talk about the individual axes, because that's kind of where the crux of this conversation is. These axes themselves, let's configure, we've got 3 axes here. Let's configure one each of the 3 different ways that you configure an object. So let's go, and axis 1, it needs to be a linear, because all of these motions are going to be, actually, it converts it inside of it. So like, I guess it doesn't really matter, but linear just makes it a little bit easier. So it is a standard motor. So it's actually a rotary motor that's going and getting changed into a linear coordinate system. But we're really concerned about these drives. So the first one that we're going to set up is just one of these drives that are on the axis that's on this control unit. Okay, obviously these aren't real setups, but we'll go from there. So let's look at, so the first way that we can look at it is the data connection is from a drive, and we select, and this is the same thing we've done many times. We go through and we select, okay, here's this CU, here's this object, and let's just pick the metering role since it's They're all positioning axes, and it brings in, because that has a Siemens 103 telegram, it brings in everything. It knows, hey, in that Siemens 103, there is encoder data built in. We're good to go. All right. So that one is greens. So again, if this is the first time you're using technology objects, then if you don't have any red, you were technically able to attempt to run the technology object, but things like position limits, dynamic limits might not be set right. So it might not run in a way that you expect. So yeah, again, this is your first time on stream. Welcome. Drop where you're from, where you're watching from. We always love the international community that we have here. And if you are liking the stream so far, go ahead and hit that like. Maybe we can get more people in here and join in the conversation. And if you haven't subscribed, why not? I mean, if it's your first time, then this is your first opportunity to subscribe, right? But yeah, I mean, I guess if you don't like the stream, you could be like the one person that dislikes my stuff. I don't know who, but well, I have an idea of who it could be. There's two possibilities. But anyway, so let's move on to the second axis. And the way we're going to configure it is, instead of doing a drive type Profi drive, so like Ethernet, TCP, something like that, let's just do an analog drive connection. Now, in this case, we don't have an analog output, I don't think, to be able to so activate enabled output, analog output. Okay, so yeah, I don't have any analog output. So in order to do this, what you could do is, like, if you had just an analog controlled drive, like an older DC drive, even that doesn't even have Ethernet, or anything that doesn't even have a Profi drive connection that shows up in like a GSD file. It's literally just like, let's just go in here and add in an analog card and see if we can do this. So rack AQ. Oh, Iran. Welcome from Iran. So we've got some outputs, and then let's put an input card in here. Let's see if this will work. All right. So save, compile. So we're going to notice also too that some of this stuff doesn't really work that well. Oh, we haven't done something or something. Oh yeah. So it doesn't like, oh yeah, because none of that's fine. So we're going to notice that we're going to have to compile at different times. Otherwise we get errors in red and green and stuff like that. And so, yeah, so just trying to set up this axis 2, and we needed to try and get a, active interface drive is not interconnected. Output address of the drive telegram where the analog set point is not set. Duh, I haven't done that yet. Okay. So, wasn't that simple. Let's do this. So, as you can tell, this is live and unplanned. So it might be that this is not, no, UI, that should work. So let's get the addresses here, and let's just do it. How about let's just do this? And make that. And now we should just be able to copy that into here. Ah, there it is. You just needed a tag. So, all right. And then from our encoder connection, so because we need some sort of feedback in, right? This is where we're going to have to figure out some sort of feedback, like coming back in. Because if you don't have an encoder, you got all sorts of issues. So we're going to use this, and we're going to come back to this here in a minute, because this data feedback, you got to have this feedback. And so we're kind of running into this little problem here. So the third type of connection, and by the way, I noticed on this Axis 1 here, when we were connecting up the drive, that I actually had an option for that Dynamics VPN, or that Telegram 102 that we made, which that is something new. It used to not be available for technology objects. So this is a great improvement for the V90. And I know a lot of you guys out there are using V90s, and while most of the time the people that use the V90 are using it for their cost savings, but a lot of times you just need a small motor. And so one of the things is I'm about to come into possession of a couple of these V90 motors. And so we might be setting up a kinematic, a thing like an actual Delta picker, and I might just 3D print up a Delta picker setup just so we can really play with this stuff later. But yeah, so stay tuned. So the third way, and this is the way for my friends that are in Belgium that reached out. They have a yes. Hey, Measure, you got a 3D printer, don't you? You can help with the Delta picker object. I always forget to mute my Discord. So okay. But yeah, so we're going to be making a Delta picker. It'll be with V90s probably, unless somebody is watching this from Siemens and wants to get me some demo equipment. Maybe that the technology object demo with the multiple S210s. How about that? I mean, there's always that, right? Yeah, talk to Matt about that Measure, okay? Get that plug. But so what are we doing? I'm distracted. So we're connecting up from this type of the third type. So in this scenario, we have a device that is connecting using a Modbus gateway. And so there's a couple of different ways that you could bring in Modbus TCP data. And we've done it before. There's a Modbus TCP client, that a client block, and maybe I'll link it in the description later, or put a comment or something on here. But if you have this Modbus data, that Modbus TCP data that you're sending out to the individual motors of, say, like a Delta picker that you've bought, that you've bought this physical rack that has these motors and these kind of Modbus drives on it, and you're wanting to use the Siemens technology object. Well, you're not able to bring in the Modbus data into this network. So with the V90, we were able to bring it into the Profi drive, and so there's a what's it called? A telegram that we can make available that we can tie into this technology object. Well, with Modbus, it won't be here. It won't be in this setup. It's just reaching out to an IP address, populating a data block. So what we could do is we're going to make a data block that's called drive Modbus drive data. Okay. All right. So we have this Modbus drive data, and there's a couple of different ways that we could do this. And just so that you keep the cycles separated out, I would have two separate data blocks, and I'll show you what you mean. What we're going to be doing is we're going to be bringing in the Modbus data into this data block. Then we are going to be transferring this into and creating essentially a Siemens Telegram 103. And then we are going to be using that fake 103 telegram in our technology object. So what we're going to do first, because we need to set this up first, and I'm going to show you, there is, and don't think that I'm like some sort of like genius or whatever. There is literally a document for this. It is the motion control manual. So 1500T motion control overview function manual, English US. Yeah. So I'll send the link to where you can find this. Actually, here, if you know how to use, maybe not. normally there's a all right. Normally maybe it's all the way up at the top. There's a support ID function for it. So if you were to go and like search for this on Siemens support website, this document name, function manual, let's see if this does it. I have the support. Let's do that. Make another one. Let's see if I search that number, if it shows up. Yes, it does. So it does. So if you search this number here in the SIOS website, you will get this, and it is on page 85 of what we are doing right now. And yeah, so really cool document. But what we're going to be doing is we need to modify. We're going to create another data block called TO Telegram, or we'll say Axis 3 Telegram. Okay. Now we go ahead and global DB, make that. And a couple of things that it said that we needed to do. We needed to right click on it, go to properties. We needed to make sure this is unchecked. And we need to uncheck optimize block access. Okay. So that was what this document says here. So disable the following attributes: write protected device, optimize block access, only store and load memory. So only store and load memory, that, and then write protected. So these top three we need to unselect, say okay, and that makes it to where we are able to actually connect and create what we're about to create. So the next thing that it says is on the add new tag. This is the cool little thing. Okay, so this is what Measure was talking about earlier, about having these telegrams built into TIA Portal. And when you enter the new tag, you just type in PD _ tel 103 and hit enter. It won't show up anything. It just, you're an advanced Siemens programmer. You are an advanced motion control programmer. And so when you do that, it recognizes your superior ability and it loads it in for you. Because otherwise I would have no idea how to get it. So we're just going to name this Axis 3 Telegram. Okay. And in the type, we are going to do PD _ tel 103, and of course I already have it in there from before, but we click enter. If you didn't have it in there, that little pop-up box wouldn't have shown up. It would have, it had just been like, trust me, bro, I know what it is. And there we go. We have our telegram now here. So what we can do now is go to Axis 3, and on our drive, we can go Profi drive. We can go data connection is Datablock, because it's still saying it's treating it like a Profi drive. It's treating it like a telegram. And then we're going to go and select our Axis 3 telegram. And then there's our telegram. Okay. And it doesn't work. What the crap? Oh, that's right. Remember talking earlier about having to compile a bunch of stuff all the time? So just do a hardware rebuild all, and then do a software rebuild all. And where I'm clicking that is I'm clicking underneath on the actual PLC itself, right clicking, and then going down to compile hardware and software only changes. Sometimes that doesn't catch stuff. Don't ask me why, but just do both of the rebuild alls, and that forces just a rebuild. And you'll notice here, my drive and encoder in my technology object, they're happy, right? They are accepting this configuration. But we know that Axis 3 telegram, this isn't getting populated by anything. It's just a placeholder. It's just something sitting there. Where the data is really coming into from our Modbus data is coming in at this Modbus drive data. Okay. And so what we would want to do is have part of our program take our Modbus data from our Modbus TCP client, and we would want to populate this. We would want to do this. So we would say Modbus telegram. Okay. And we would want to have this same PD underscore tel 103, right? We would want to have that. And the reason why I said that you wouldn't necessarily want to have these in the same thing is because you might want some other data here, right? Like you might want real, you might be bringing in other stuff like statuses. You might have some calculation. You might have like whatever. I mean, anything. So you might have all this stuff that you're wanting, but you're wanting, you are wanting to have this clear Axis 3 telegram block that is set up specifically to connect into this drive object or a technology object. And so now what you would do is you would go through and populate this telegram. So the input, so what's coming in, make sure everything meets the standards. So a lot of this stuff is probably already there. The big difference though is going to be this stuff here. So the XIST1 and XIST2, those are the instantaneous positions. And so that's the encoder data. And this actually has two encoders in the 103, but fortunately for you, you don't need this second. So if you only have one encoder, you don't have to populate the second one, or you can just populate them the same. Like, so you're going to go through and get your Modbus data, and then you're going to do whatever it takes to jam it all into these input and output telegrams. Okay. And this is the interface that your Modbus client is going to be working and populating this data block. Now, how do we get that into that other telegram? And there's a very specific way that we are going to have to do this, because if you're not familiar with the technology objects, the way that they work is every function and everything that's working in the technology object. So all of your MC home, MC power, MC reset, MC moves, all of those, all the MC blocks are actually being analyzed in what is called an MC servo. So OB91. And OB91 is what is set by your, or the, how often it gets updated is your motion control update time. Out of the box, most of the time it's like 2 milliseconds, which is like crazy fast for most stuff. And it's an interrupt. And if you're familiar with the way interrupts work, that means that the shorter the time period that you have on that motion control cycle, so OB91, the more your main program is going to be. So OB1 is going to get updated. So if you have a really short, if you have a lot of technology objects in a really short update time, it's going to interrupt your main cycle a lot. So just be wary about the fact that, oh, hey, if I'm doing some important calculation and I'm doing it in OB1, it might only be getting updated every 40 or 50 milliseconds, which is really fast, but sometimes it's not fast enough, especially if you are expecting that data to be calculated every cycle of a motion control cycle. So in order to correct for this, there are 2 organizational blocks, and we're going to add them in. They are called MC, so motion control. So MC pre-servo and MC post-servo. And we're going to add in both of these, and you can probably guess what their purpose is just by the name. But when we add these into our program, it gives us the ability to, if we want to do a calculation that you are guaranteeing that that action will be performed before the MC servo cycle happens. So what will happen if you have MC post servo and MC pre servo loaded into your program? What will happen is every servo cycle, it will run MC pre servo, then run MC servo, which is all of your MC commands, all of that stuff, and then after that, it will run MC post servo based on all of what was done right then. So that means all of that data, all of those data blocks, everything that gets updated in your motion control gets updated before post servo, and your pre-servo is guaranteeing to update it. So here's what we want to do. So we're looking at MC pre-servo, and again, we're just going to do a move, and we're going to move this. We're going to move this Modbus drive data. We're going to move this telegram onto our Axis 3 telegram. Actually, no, that's not right. We don't need to do that. We need to move just the input data in pre-servo. So we're only moving the input data. One thing about when you are working inside of interrupts, and this is kind of like just a general rule of thumb. If you are working inside any OB other than a OB1, you really need to be efficient with what you're doing. So what I mean by efficiency is, what I've done here is I'm loading both the input and output telegram. And it doesn't sound like much, but any time that you are spending inside of this MC pre-servo, you can't run your MC servo and you can't run your main block. So everything else gets jacked up. And so while it may not take but just like a couple of cycles to be able to do that, if you have multiple axes that you're doing, say you have 10 axes that you're doing this on, that could add up to an actual significant amount of time and could delay your OB1 by a considerable amount. So instead of moving the whole telegram, let's only move part of the telegram. And so let's go to Modbus drive data. Let's go to the Modbus telegram, and we only need to move the input, okay? And this should not like this because it's not the same size. And so this is just the input that we're going to transfer from the Modbus data into the actual Axis telegram data. So let's go here, and now we want to transfer that into the input. So there, now everything's happy. Get in, get out. That's the rule with interrupts. Get in, get out. Don't spend any more time that you have to be in there. And that's all that we have to do here. So let's go to MC post servo, and we're going to do the same thing. We're going to do a move, except we're going to move the outputs out now. So we want, actually, we go ahead and throw this into the output. So this is the Telegram Axis 3 Telegram output. And am I doing that backwards? Yep, I am. Remember the direction. So we've got all of this stuff that is inside MC servo that's happening. And what's getting updated? Well, it is updating, taking the input information, so like encoder feedback, actual speed, drive status, stuff like that. It's bringing all that in. It's processing stuff inside of there. And then it's sending stuff out. So we want MC servo is updating the outputs, and now we want to send the outputs into our Modbus data block. And so that's why we're doing it in this order. Yeah, and if this information is helpful, like I don't know anywhere else where this has been put together, like on the internet. It took quite a while when I first did this topic to like dig out how to do this information, and it's a little bit dangerous information, so be very careful with what you're doing here. But it opens up an incredible world. Okay, so if this is helpful and you have some like people that you know that could use this information, share it on social media, share it on LinkedIn, share it on whatever, like get it out there, and we can get more of this type of content that way. So at this point, technically you are set up, ready to go. Now, I will say that there is a lot of testing that needs to be done, because I've kind of like hand waved over the fact that this Modbus data that's coming back from your drive is actually correct. I have no idea if it's correct, because I don't know if whatever drive that you are using is going to adhere to the same standards. Now, when you look at this stuff, you can go through and like, let's look at this Modbus drive data, for example. So like the input data, we click into this and you can kind of like, okay, hey, node speed deviation. Some of this stuff you could just say, you can kind of just put in there. Like a lot of this stuff is just speed comparison value reached, exceeded. Like there's a lot of the stuff that may already be available in your drive. And then some of the stuff you're just like fault, operation enable, ready to operate, ready to switch on. Like those may be like you just have to build up this telegram. The most difficult thing by far is going to be this X instantaneous 1 and 2. So like your encoder feedback data. Fortunately, there's a document right there. Simple, right? Here is what the definition for this encoder values is. And so let me give you entry ID again. I'll throw this over into chat and search this number in SIOS, the Siemens Industrial Online Support website, and you will get this document. And again, you're not here because you're doing the simple thing. This is a very complicated thing, okay? And so this is some of the most high-end type of like programming and stuff that you could do on these Siemens drives, and you really need to know about the hardware. But your definitions for these different status words like GSW or like G1 CSW, okay? For example, this probably isn't being used in our data here. No, it absolutely is. So this right here, all of this here, here's these definitions. Definitions of G1, ZSW, status word, all of this stuff. Okay. So these are the things that will be getting flipped. And obviously on the output side, if there's nothing in the Modbus, nothing in the user's drive, whatever that you're trying to use, if there's nothing there that equates to it, just leave it alone. Like, just don't do anything with it. You don't have to transfer it. It's the input that is kind of the really important thing to the drive or to the technology object, because it's taking and it's using this definition for this X instantaneous. So here's what you're doing. It's a little bit outside of the scope of what we're actually doing here. But I will say, if you are using, so this is an incremental value for X instantaneous. It tells you the definition of it. Here is the absolute value for X instantaneous. So this is that X instantaneous 2, right? So let's hop back over here, and we've got this X instantaneous 1 and X instantaneous 2. So that's the incremental value and the absolute value. So a little difficult and a little bit outside of what we are doing here. And if you're getting into something like this, then you're going to need to kind of know, hey, this is tough. Probably though, because these values are in like a standard telegram, it's probably already done for you, and you just have to find the right place to get the data. So hopefully that's the case. But here's the definition of that X instantaneous 1 and X instantaneous 2. And really, that is about it. So how y'all doing? How's everybody doing? Is everybody, lost almost everyone. Yeah, this is the deep stuff. We're about to get into the HMI stuff that's a lot more accessible to people. But for those that have been hanging on into this topic, congratulations. Like, for real, you should be proud, because this hurts my head, and it's taken me many years of my head hurting to be able to even talk like I know what I'm doing. But honestly, the only way that you can know about what data is available is to try it out. And so, yeah, as always, if you have questions and you're watching this on demand and you have questions, you could comment. We can get in touch via on LinkedIn, some other place. Like, feel free to share, like, comment, subscribe, all that stuff, to get in contact. Hopefully here in a few weeks, we will have some more options just with like forums and memberships and things like that. But right now, hit me up with a comment, find me on LinkedIn, and yeah, we can go from there. For those that are still on, we're going to relax our brain. We're going to unwind a little bit. But I will say, I'm going to close all this stuff. And again, MC pre-servo, MC post-servo, if you're working in those, just be sure to be efficient. don't do anything in an organizational block that's like extra stuff. So even in like a cyclic interrupt, that's like you're doing in like every 100 milliseconds or so, you can run like a PID block and stuff in those. Sure, that's fine. Be sure that you don't get those update times too low, because you can actually start, especially if you're using MC Servo, you can start interrupting interrupts, and it works about as well as it sounds like it would. There is a way that you can set your system up to where your like OB1 just doesn't run. It interrupts are interrupting interrupts, and then it never is able to actually complete the original interrupts, and your cycle execution stops, and all you're doing is just running interrupts. Now, you might want to design your system like that. Well, I don't know why you would want to, but you don't have to do things in OB1. I was talking to a customer that they were having these issues, and with cycle times that they were seeing as being a little long. And I mean, for what they were using in OB1, it might not be a problem, because everything that they were using that was important was pretty much being done in cyclic blocks. So they were either motion control or technology objects, but they were being done every 4 milliseconds. So in actuality, all their calculations were being updated every 4 milliseconds. So, but yeah. So we are transitioning now into our HMI topics. So last week we brought in our little BALA sensor. It wasn't on this project, it was on a different project, but I'm just going to add in an HMI on here. Oh, I'm already there. Derp. So hardware catalog, I'm already there. So let's add in a comfort panel. Let's say 15-inch. We got some of these in the shop. So TP6AV QC. No. Anyway, we're gonna throw one of these in here. The reason I'm doing this is so we can talk about scripting. I'm using a comfort panel just so we don't get restricted by something that I don't know about. Let's do drive our live HMI, right? And I don't know which one these are. Which one is this? Ethernet. I think they're both fine. So on the 15-inch, you have multiple interfaces, X1 and X2, whatever. Let's just connect this up. That, because we need to have a connection back to the device. So when we pull in tags, it makes the tags. So what we're going to do, anytime you add in HMIs, saves get like what are you doing? But yeah, so what we're going to do is I'm going to introduce some scripting stuff, concept of scripting. So let's just make a screen. Yeah. And we're going to name it main screen. Rename. My microphone's like blocking it. And so real simple stuff. I mean, so one of the thing about creating scripts is there's a couple of concepts. So scripts have to be called. And no matter if you're writing them, so on a comfort panel, the only scripting option you have is a VB script. Okay, but if you're using another SCADA platform like WinCC Professional or I guess, yeah, WinCC like 7X or something like that, there's a couple of different platforms, and in those you could do C scripting, so you can use different languages. For this, it's VB, and if you're not familiar with VB, if you've ever run Excel, it's pretty much Excel. You just get access to some different functions, and we're going to go through some of those basic functions today. So the first thing we're going to do is I'm just going to go through and show you the basics about like the core function of a script. So remember, you have to activate a script. So it's not quite like a full program. The easiest way to activate a script is if I'm clicking on this and going to properties, and you could say events, and there's a loaded and a cleared event. So whenever this main screen is loaded, you can tie a function, which we can tie a script to. So let's go through and add in a new VB script, and let's just call it like our script. Okay, and so if you notice now, we could go in here and we have a place VB functions, our script. So now when this page is loaded, it will run once through this function. Now, this is pretty simple. And this isn't going to be like a programming class just per se. It's just introducing you to the core concepts of how to use a VB or VB scripts in Comfort Panel, because there's a couple of things that you could kind of like look up, but there's things that are specific to the scripting language, how to gain access to like tags and properties and things, and that's what we're going to go through today. So one of the things, if you're not familiar with it, because this is VB, dim my, okay, so dim is just a variable, and VB, instead of actually defining the type of your variable, it defines the type when it gets first used. So you declare like a dim. This is inside this script. This is a variable inside this script only. And so there are ways that you can like create like variables and things outside of it, and that's through global tags. And so the only way that you can share data in between scripts is through global tags, and because there's no environment that this is like running in. Now, I will say, I may be wrong on that. There might be a way, and if you actually know, if you know a way to do this, feel free to chime in. And so what we're going to do here is just kind of talking about the basics. So I've defined this variable, my object. Now, say I'm wanting to do something like, I have a box here, or this is a button, right? So you have your objects, you have your elements, and so let's have this button here. And so this button, we're going to call, not that, not what I wanted. Well, we'll just do it this way. So we have this button 1 right now, okay? And I won't modify the name. But if we wanted to say, for example, we want to burrow into and change the properties of this of this button. Say we want to move the position of this button dynamically for some reason. We can do that by using what is called this HMI runtime, and then we'll have these little objects. Now, you'll see me looking over to this side here because I have a little bit of thing here. Help. Again, I don't use this sort of stuff very often, and this is very, very rudimentary. But I want to introduce you to two topics, or two kind of like thoughts. One is how to gain access to the properties of an object on the screen, and then how to access tags. And then that is the basic core functions that you want to do, so that you can kind of do some math and then like change a tag. Will get you to where you can do that. So an object on the screen, if you want to kind of like bring in this object, okay? So you want to use the set command, and then you want my object object. This is hard, like with the microphone right in my face. Set my object equal to, and then this is this HMI runtime dot screens, and I'm going to explain this. So I double click screens, and then I'm going to pick in main screen dot screen items, and we are going to use button underscore 1, right? And then white space is the delineator on the end, and we can check our syntax to see if that's worked. And so yeah, syntax is good. So again, I'm looking at the compile screen underneath info in our inspector window. Control 5 can drop that out. Control 5 will bring it back. And so now we have this set my object. So this button 1 is there. And so now what we can do is we can do like my object. And so we can do things like my object dot for color, or if we want to move like its size. So yeah, so like we can change the width dot width. We can either set that equal to like a fixed unit, right? So very simple. My object, I've picked the object off of the screen with this HMI runtime screens, pick the screen, pick the object on the screen, and then what I've done is created this my object, right? Well, there's another way that you could have done this, right? So if you're familiar with these programming languages, these are kind of object oriented. So if you were just wanting to set the width of this to be 100, you wouldn't have to use this my object. So you could absolutely go through and just take this little portion here, and then we're going to delete this, all of this, and then we're just going to delete this, right? So that should check out. Yep. Because what this is creating this object, right? It's going through and creating this pulling out this object, and you are changing the width of that button 1. You are changing the width to 100 without even using this my object. So that's two different ways of doing that same thing. Now, why would you want to do that? like you could dynamize this or make it dynamic based on, say, a tag, a screen tag. So how do you get access to the tag though? So it is with a function called smart tags. This smart tags, and if you notice, for some reason mine is like going gray. In my example, it's a burgundy color, but gray is these system functions that are available to you. So smart tags, and now I would put a tag in, but I don't have any HMI tags. So let's just say, let's make a tag that's tied to a, say for example, I don't know, let's just make a tag here. And okay. And so now you would want to make a tag that is in our tag table. You'd want to link it. So there's a manual way of doing this. Let's see if we can figure out the automatic way. So we're going to open up our default tag table. Now I'm going to go back and click on that. I'm going to click on that safety data, and then I'm going to drag this size over into here, into our default tag table. It creates this HMI connection. It creates that. So data type real, good to go, right? And it named it safety data size. Okay. That might not work, but we're going to cut and paste that, and we're going to go back into our script. We're going to put that here, and it does not like that because it has to be in quotes. And we're going to close that out, and that just, it's not doing anything with it. Yeah. So we want, say for example, to take this, and instead of this being a fixed value, right? We want this to be up here, right? And it likes it. So what is that doing? What did I just show you how to do? So this is taking, we have made on our screen this little button here, okay? And inside of this button, there is a property in the layout, I believe, right, called width. And so this is, it specifies the object width, okay? And we can change these things. So this is position and size, and we can change that dynamically. Another way that you can look at kind of the properties that are available for an object are on this property list, and you probably saw where I clicked that. Well, here's all of the different things. So width is there, there's height, and if you go into your script, you can, with a there dot, it will give you all of the available options that you can modify via that. And so like vertical alignment, text on, text off, like you could change all sorts of stuff via these scripts. And unless I have like a very specific like, hey, here's what I'm trying to do, you're really just going to have to kind of build on that. So that's really the basic structure of like how to access something on the screen, how to access, so you go HMI runtime, screen, again, it has to be in double quotes. You put the actual screen name in, you put the actual object that you're wanting, which I didn't show you. I skipped over this a second ago. I could show you this. Down at the bottom under miscellaneous is the actual object. So like this. Now I will show you something in your script. I don't think it actually, oh, never mind. I'm a liar. It updated it for you. See, so it did update it for you. I was going to say it won't update it and then you could get hung up, but actually, no, it did. So my main screen, my button, and then you can set it using the smart tags to equal this. Now, remember, my object, we said it's an object, but if you say set my object, it does not like this. Let me do this. Dot width. Just put it to something because otherwise that'll complain. So set my object to so a set is a function inside, or I guess it's a method of the screen, the HMI screens. So so I guess it's a screen items. Yeah. So the set method is part of this screen items thing here. But so let's see. So my object, if that equals, let's just do this smart tags here. Let's see if that works. That should be fine. Yeah. So now this calls this as a tag. And so it just sets equal to my object is to whatever that tag is. And so now at this point, you can go like my object equals my object plus 1, right? And that should be fine with that. Yep. So it's okay with that. So that would just increment whatever that value is. And the crazy thing about, and to me, you don't have to declare your variables. You just use dim, and that's a VB thing. And again, honestly, Excel, this is what kind of makes Excel so powerful, is that you can do this sort of scripting. Now, I guess probably last thing that I'm probably going to talk about on this is how to call these things. Okay, so we've talked about like on a screen load, right? Well, once you have this script, the thing about it is you can set up a function to where a script to where it runs indefinitely. So like you can set up in here like a do while, right? Or like, yeah, so a while. So you can literally do while true, and this will run forever, right? So if you're not familiar with these syntaxes, then all right, that's probably a little bit different thing. And maybe if we have a little bit of discussion in the comments about what you would like to see more about scripting, like individually about scripting, then we could go through this. But the way that we have this main screen set up, we load in this screen, and while this is running, it will start running this script. And so it loads in. And the way I have this while loop set up, it's going to run this while loop forever. Now, do you want to do that continuously? I don't know. But you can. Most of the time, you're going to want to do this like while there's these screen objects. So like system functions. So there's like the screen is active and things like that. So you can get all of these different screens. So like while screen is active, something like that. It's just running in the background. You can absolutely do something like that. But yeah, so that's the basics of scripting, and you can do a ton with this. Like in this scripting, you can bring in bring in code that like is accessing databases, for example. I did a project that uses this scripting. Gosh, back when I first started as an intern back at the mines when I was in college, and it used this scripting to log data into a database, and it was using an ODBC connection, which isn't the best type of connection, but it was real simple to set up because you could just use these ODBC functions and create these SQL queries and make this stuff in the database. And so you can absolutely do SQL interfacing with this. One of the things that I kind of talked about maybe doing last week, but I mean, we're coming up on about 2 hours now, or an hour and 45 minutes, was logging in and logging out of user administration. And so there is a function in here to where you can set the user admin and password. So you can go in and let's see, let's find it. I think it's log on. Yeah, log on right here. So this log on, and then I think it will show it. If you click F1 on it, maybe not. So this function, oh, it's this up here. This little button here displays information about the parameter. And so the log on, password, and then username in terms of tags. And so you can pull these using the smart tags. So you can pull in, so this would be like log on, I believe it would be, yeah, here you go. So log on, then we could use like a smart tags. We could use that smart tags thing to pull in a tag, or if we've already made our tag somehow, we could go in and do this. And so remember last week, what we did is we had our little, our BALF sensor that had our little RFID tags that had a tag reader. So there are some software packages that tie this into like like Windows logon servers and like all of these like IT kind of programs and things that are kind of complicated. There are paid software packages that you can load onto your HMIs that access all of this stuff. But with this logon here, the way that you can access this logon function is accessing a password and a username from your HMI user administration. So we go to user administration and you can set up these users. And so it can be whatever, Jason. And then the password is whatever. Not the word password. Not the word password. And so you can set this up like this. And so maybe next time what we'll do is we'll go in and actually set up user administration to take an interface with that BALF and create a protected user list that has usernames and passwords associated with these cards. And so you associate a card on your PLC, you associate the card, and then locally we use a script. When we load in the page, it goes in and logs in whatever those tags are on the kind of like in the logged on password. So what we could do is we could set up, because remember we had the little device that said, hey, there's a card here. And we could say, if there's a card here, load in the username and password, right? And so what you could go through and say is, if you're sitting here running and looking at the user administration and everything, and if you put your tag in, that little card present bit comes on and it logs you on automatically based on your tag. How about maybe we can kind of go through and do that on the next stream, because I think that would be pretty cool to actually complete that kind of like arc of creating an HMI that is interfaced into a PLC, that you're not having to set up any sort of like crazy over the top user administration. This is a simple program that has a couple of users that you just go through and set, and then create a page on your HMI that has kind of a user administration page, and you log in and say, all right, here's this tag. I'm logged in as a user admin. I'm setting up this tag is this person, and it goes through and it does it all dynamically, because you can actually do all of that from scripting, and it's pretty cool. Because if I remember correctly, there is a like create user or something. I'd have to find it, but there's like user administration dot whatever, but there's a lot of stuff that you can actually do dynamically through this scripting, and I think that'd probably be a good like next session. So yeah, I mean, this has been a little bit of shorter of a stream, and we talked about some really deep stuff in the first hour, and then got this introduction to HMI scripting. And so I'm sure that for those of you that are involved in these kind of like crazy projects, that these crazy drive projects, that first part is really helpful. 99.9% of people, you're probably not going to really use it. But if you are, be sure to share this stream, share this channel, get the word out there, because we're wanting to grow this community. And the more we grow the community, the more useful the information that comes out of these streams is. Next time, we'll probably be doing a little bit more about this HMI scripting. We'll be wrapping up this project. I'll say wrapping up. There's always something new that we could do. I've got another type of scanner that we could do. It's an actual Profinet scanner, and the reason I didn't introduce it last time was honestly, I don't think these cards are quite big enough. These are just kind of like really simple access cards, and the Profinet Ballup scanner is kind of advanced, and it wants to have, it really wants to be like in an automotive plant where you have a ton of information about a piece of equipment or whatever that's coming by. Say you have an engine that has all these different like all this information, and it has like 10 megabytes or 100 megabytes of data that's built into its little RFID tag. That sensor is made for that. And so, but yeah, so without any more, be sure that if this is your first time on the stream and you've enjoyed it, please like it. Please. And also, if you're not subscribed, and if you want to get notified when we do go live, because I do run a business. I am an active engineer. So unfortunately, my streams aren't always at the exact same time every week, even though I try to. We will try to get back to the 10 o'clock, 11 o'clock on Fridays, but no promises. If you haven't rung the bell on your subscription, though, that's the way that you can be notified. Hey, Jason's live. And if you're available to sit down with coffee and join in, you can. But yeah, as always, thank you so much for your support on this channel. It has been growing. It has been a wonderful, wonderful journey so far. I've loved talking to people that are going through all of their automation journeys and kind of every step of the way. I love being involved as much as can. And yeah, as always, thank you for joining, and hope that you will have a great rest of your week. And well, it's a weekend, right? So yeah, yeah, but yeah, so have a great weekend, everyone. Y'all, till next time, catch you later. Bye.